Finally, let's introduce some terminology around binding because this is going to be useful to have going forward. So for every identifier that appears in our Mo program, one of the three words below applies to it. It's either a binding identifier, a bound identifier, or a free identifier. Binding identifiers are like the x in let x equals 5. So on the left-hand side of the equals sign, that's a binding for x that assigns a meaning to it going forward. Functions also create a binding. So the function argument, in this case x, that is a binding position that says x is going to have a meaning once we call the function. Bound identifiers occur in expression positions. So here if we have let x equals 5, first we create a binding for x, and then any x's that appear inside the let body, those are bound to the outer binding. And then similarly for functions. Free identifiers have no binding. So if we say let x equals 5, and then we suddenly have a y inside the let body, that y is free. And functions can also have free identifiers on the inside. Here's a slightly bigger example. So let x equals 5, let y equals x, y plus z plus x. The x and the y on the left-hand side of the let, those are both in binding positions. And down below, everything that's in green, that's a bound variable. So x, y, x, those are all bound to bindings that come up above. And the z is colored in red, that's a free z. There's no binding for it. Another reason this terminology is useful to have is because it applies to relative expressions. So if we focus just on the let on the inside, relative to this let, all the x's are free. And the y is still bound. So the y is in green, that refers up to the blue binding y, and the x's are unbound in this colored expression. If we swap our y, so now we have two bindings for x, and we see y is unbound inside the body, the x's remain bound. And if we focus just on this inner let, we see that the x on the right-hand side is free relative to that expression. It's sometimes useful to draw arrows to show what does a bound identifier refer to, what's the binding that it refers to. So that's drawn here. And Dr. Rackett will also draw these arrows for you. So here we've got a binding for x, and we have arrows down that refer to the two bound occurrences. Function definitions also create bindings. So if the function has argument x, that creates a binding that variables inside the function body can refer up to. So the x's inside the body here are bound to that argument binding. And the function name itself also makes a kind of binding. So when we have a call later on to double of 3, that's a bound variable double that refers up to the function